Namaste my dear students, welcome back to physics online class. Let us continue our discussion on the topic capacitors and capacitance. In the last class we have derived an expression for capacitance of a parallel plate capacitor. Now a parallel plate capacitor is nothing but two metal sheets separated by a small distance. In between those two metal sheets we know that there will be a dielectric medium. In the last class, while deriving that expression for capacitance of a parallel plate capacitor, we considered air as dielectric medium between the plates of capacitor. Now the expression we got in the last derivation is capacitance of a parallel plate capacitor is given by C is equal to epsilon naught A divided by D. Here epsilon naught represents permittivity of free space, A represents area of each plate. If this is the conducting sheet used in manufacturing a capacitor, then this area is area of the plates. Area of the plates, it will be same for both the plates of the capacitors. D is the separation between the plates. We represented the capacitor like this. One plate. We know that a capacitor is a system consisting of two identical conductors separated by a small distance. In one conductor charge is stored, that is, if it is positive charge, charging by induction takes place. Second conductor is a grounded conductor, therefore only negative charges will remain on the surface of this conductor, on the surface of, or in case of that conductor, so that this forms the capacitor. Separation between the plates of capacitor means this distance, separation between the plates of capacitor, that is D. Okay. Now this is the expression for capacitance of a parallel plate capacitor. Now this derivation is important from the point of view of board examination. You can expect that derivation for 3 marks. Derive an expression for capacitance of a parallel plate capacitor, important derivation. Next 2 more questions we can expect from this part, that is, first one is, another question in this part is, on what factors does the capacitance of a parallel plate capacitor depend? Okay, the factors on which capacitance of a parallel plate capacitor depend. On what factors does the capacitance of a parallel plate capacitor depend? So nothing to worry about this part. We have an expression, that is C is equal to epsilon naught A divided by D. That means capacitance of a parallel plate capacitor depends on, first factor is A, that is area of the plates. Capacitance of a parallel plate capacitor depends on area of the plates used in the capacitor. Capacitance of a parallel plate capacitor depends on, second factor, that is in the denominator, that is distance between the plates of capacitor, or separation between the plates of capacitor, between the plates, separation between the plates of capacitor. And third factor is, in the expression we have one more term, that is epsilon naught. Epsilon naught is permittivity of free space. That is when, see, this expression is valid when the spacing between the capacitor, plates of capacitor, is filled with air. Okay, air capacitor, in case of air capacitor. That means if you replace that medium, that is air between the plates of capacitor, by some other dielectric medium, instead of epsilon naught we have to use permittivity of that particular medium. That means it depends on the medium totally. How exactly it depends, we will discuss later. Okay, now it depends on the medium. Capacitance of a parallel plate capacitor depends on the medium between the plates of the capacitor. The dielectric medium, actually it is dielectric medium between the plates of capacitor. On these 3 factors, capacitance of a parallel plate capacitor depends. Area of the plates, distance between the plates, and medium between the plates of capacitor. These 3 are the factors. Next, one more possibility. Second one, how to increase the capacitance? How to increase the capacitance of a parallel plate capacitor? By what method you can increase the capacitance of a parallel plate capacitor? That can be asked in the exam for 3 marks. Okay, so what are the possibilities? See, from the expression, capacitance depends directly on area of the plates, isn't it? C is directly proportional to area. Therefore, first method to increase the capacitance of a parallel plate capacitor, capacitance can be increased by increasing area of the plates. Capacitance can be increased by increasing the area of plates. If A value is increased, then automatically capacitance value increases. This is because capacitance of a parallel plate capacitor is directly proportional to D. Second possibility is, second one, D, it is in the denominator. Capacitance of the parallel plate capacitor can be increased by, D is in the denominator. If you decrease D, then only capacitance increases. So increased by decreasing the distance between the plates. Okay, decreasing the distance between the plates. This is because capacitance is inversely proportional to D. Third possibility is C. See, when the medium between the plates of capacitor is changed, that term comes here. Instead of epsilon naught, that is for air, you have to use permittivity of that particular medium. So capacitance can be increased, C can be increased by using a dielectric medium of higher dielectric constant. Between the plates. So this is the third possibility. How to increase the capacitance of a parallel plate capacitor? That is possible by 3 ways. Capacitance can be increased by increasing the area of the plates. Capacitance can be increased by decreasing the distance between the plates, and capacitance can be increased by using a dielectric medium of higher dielectric constant between the plates. These are the 3 possibilities. On these 3 factors, capacitance depends, and these are the 3 methods to increase the capacitance of a parallel plate capacitor. Okay, important from the point of view of board examination. Okay. Let us move further. Now consider a parallel plate capacitor. See, this is the symbol of parallel plate capacitor symbol. Okay, this is the symbol of capacitor, circuit symbol. Whenever we write the circuit that consisting of capacitor, you will find this symbol, that is the symbol of capacitor. Now let us consider a parallel plate capacitor. Now this part represents one conductor, another identical conductor. I'll write it here. Now these 2 parts represents connecting wire. It is a circuit device, or it is an electronic device. That means it is connected to some external circuit. For that connecting purpose, these 2 connections or wires are provided. Actually, this is one of the plate, and this is the second plate or second conductor of the capacitor. We know that in case of capacitor, if plus Q is the amount of charge stored in first conductor, then same amount of negative charge will be stored in the second conductor, plus and minus. So positive on the second plate, equal amount of negative charge will be stored, positive and negative. Next, this side is positively charged and this side is negatively charged. That means between the plates of capacitor there will be an electric field which is directed from positive to negative. Now this is the direction of electric field between the plates of capacitor. let the gap between the plates be filled with air, dielectric medium air, okay, electric field. In the last derivation, that is while deriving the expression for capacitance of a parallel plate capacitor, in the first step we got the expression for strength of electric field between the plates of capacitor, that is given by sigma divided by epsilon naught. Sigma divided by epsilon naught. The same thing can be written as Q divided by epsilon naught into A, because sigma, charge density, surface density of charge is equal to charge divided by area, okay, Q divided by A. Next, we calculated the potential difference between the plates of capacitor, that is force into displacement. Potential difference is nothing but it is the amount of work done in shifting the unit positive charge from negatively charged plate to positively charged plate against the electric field, and the expression for that potential is E into D, which can be written as, if you substitute this, Q into D divided by epsilon naught into A is the expression for potential difference. Next, capacitance. The definition of capacitance is that it is the ratio of amount of charge stored in the system divided by potential, Q divided by V. Okay, Q divided by V. So we used this formula to calculate the capacitance of the capacitor. Now what is the amount of charge stored in the capacitor? That is given by, if you rearrange this, you will get Q is equal to C into V. This is the expression for amount of charge stored in the capacitor in terms of its capacitance and potential difference between the plates of capacitor. Q is equal to C into V. Okay. Now imagine a dielectric medium of certain dielectric constant is introduced between the plates of the capacitor like this. Initially, it was an air-filled capacitor. Between the plates of capacitor, the dielectric medium was air. Now I replace that air by a dielectric medium, non-conducting medium, okay, non-conducting medium of dielectric constant K. Let K be the dielectric constant of this particular medium. Now what happens? Now it is a dielectric medium. When a dielectric medium is placed in external field, polarization of dielectric takes place. Due to polarization of dielectrics, there will be net accumulation of negative charge on one side of the dielectric substance, and there will be net accumulation of positive charge on the other side of the dielectric substance, so that due to polarization an electric field is produced in a direction opposite to that of external field. We have studied this concept while discussing the dielectrics, polarization. So now electric field between the plates of capacitor is the external field. In that external field, we introduced a dielectric medium. When the dielectric medium is introduced, due to external field, polarization of that dielectric medium takes place. Due to polarization, negative and positive charges will be accumulated on two surfaces of the dielectric, which will produce an electric field, that is electric field due to polarization. What is the effect of this polarization? Effect of this polarization is, this is when air is used as dielectric medium. Now here we used a dielectric medium. When dielectric medium is used, in that case net electric field between the plates of capacitor now becomes original electric field E, this one, minus electric field produced due to polarization. What is the meaning of this statement? By introducing the dielectric medium between the plates of capacitor, we reduce the strength of electric field between the plates of capacitor. Clearly, strength of electric field between the plates of capacitor decreases. Okay. Now, what is the electric field? What is the new electric field, or what is its value in terms of original value? So in terms of original value, this difference is equal to E, that is this electric field in the absence of dielectric medium, divided by dielectric constant. When a dielectric medium is introduced between the plates of capacitor, electric field strength reduces by a factor that is called dielectric constant. So E divided by K. Now when electric field reduces by to E divided by K, electric potential is given by V is equal to E into D. Now new electric field is E divided by K, which means potential value. What is now potential? What is the potential value now? I'll represent it as V dash, let it be E dash in the presence of external field. Okay, V dash, it is equal to E is now E dash, actually it is E dash into D. Now what is E dash? E dash is E divided by K, so that is E divided by K into D. E into D is nothing but V, therefore we can write V divided by K, isn't it? So potential also, potential difference between the plates of capacitor also reduces by a factor K. Now what about the capacitance? What about the capacitance? What is the change in capacity? That is C dash is equal to, capacitance is now C dash is equal to Q divided by V is the original capacitance, that is when the dielectric between the plates of capacitor is air, that is given by this expression epsilon naught A divided by D. Now C dash is equal to Q, no change in Q. Okay, we just introduced the dielectric medium. Okay, we have not added charges or removed charges from the capacitor, we just introduced the dielectric medium, therefore charge remains as it is. Q divided by V dash is the new capacitance is equal to Q divided by V dash is V divided by K is equal to, this K comes here, K into Q divided by V, that is K into Q divided by V is C. So C dash is equal to K into C. Okay, C dash is equal to K into C. To explain this concept or to get this expression, there is a derivation in your textbook, and that is the same derivation I have given in the notes also, but this is simple explanation, simple conditions. We can get the expression for capacitance. So now what are the changes? In the absence of external field, or absence of dielectric medium, or when air is the dielectric medium between the plates of capacitor, epsilon naught A divided by D is the capacitance. Electric field is sigma divided by epsilon naught or Q by epsilon naught A. Potential difference is E into D and capacitance is Q divided by V. With this condition, we introduced a dielectric medium. See, if this is the plate of the capacitor, one plate will be here, another plate will be here. The entire region between the plates of capacitor is filled with a dielectric medium. Okay, filled with a dielectric medium. That means if you consider the area of this dielectric medium, it is equal to area of each plate. What is the thickness of this dielectric medium? Thickness of dielectric medium is equal to separation between the plates of capacitor. So we introduced such a dielectric medium between the plates of capacitor. When dielectric medium is introduced between the plates of capacitor, due to this electric field between the plates of capacitor, which is the external field, polarization of dielectric takes place. Due to polarization, an electric field will be induced in a direction opposite to that of original electric field. So net electric field after introducing dielectric medium is given by E minus EP. Direction is opposite, therefore E minus EP. Now what is its value? Its value is equal to original electric field divided by dielectric constant. Okay. When electric field reduces to E divided by K, what about potential? Potential is given by E into D. So when E reduces to E by K, potential also reduces to V divided by K. Initial value divided by K. Capacitance is given by Q by V. So when V reduces to V by K, capacitance increases. When V decreases, capacitance increases. Now what is the meaning of this statement, or what is the conclusion from this expression? By introducing the dielectric medium between the plates of capacitor without changing its dimensions. What do you mean by dimensions of the capacitor? Dimensions of a capacitor is nothing but, one is area of the plate. If you change that area of the plate, capacitance changes. If you increase area, capacitance increases. If you decrease area, capacitance decreases. And separation between the plates, it is also dimension of the capacitor. If you vary the separation between the plates of the capacitor, capacitance changes. But in this case, dimension is not altered. Without changing the dimension, just by introducing a dielectric medium between the plates of capacitor, we changed the capacitance. That was the third method to increase the capacitance of a parallel plate capacitor. When you introduce a dielectric medium between the plates of capacitor, its capacitance increases. Capacity, more amount of charge can be stored in that. That is the meaning. Okay, so its capacitance increases. Now, if you consider the dielectric constant, okay, if you consider the dielectric constant, just remember these points. In case of air, dielectric constant K is equal to 1. Okay, no difference between these two. E dash is equal to E. Due to air, the presence of air, electric field will not change. Dielectric constant K is equal to 1. Actually, here we can write 1 into K. See this equation, C dash is equal to, or from this we can write C dash is equal to, this is the case of parallel plate capacitor, K into C is given by this formula, therefore I can write K epsilon naught A divided by D. This is the expression for capacitance in terms of area and separation between the plates. Now for air, dielectric K is equal to 1, so if you put 1 here, you will get this equation, epsilon naught A into 1. Similarly, if you consider the case of a conductor, instead of a dielectric medium, if you place a conductor, if you introduce a conducting slab between the plates of capacitor, what happens is, in case of conductor also, this condition arises, accumulation of negative and positive charges on two surfaces of the conductor. That condition arises because of this external field. But in case of conductors, the electric field produced due to this rearrangement of charges will be equal to electric field, the external electric field. These two fields will be equal. If these two fields are equal, E minus EP will be 0. Okay, now this term becomes, if it is 0, then K, what is the value of K? E divided by K is equal to 0 means K is equal to infinity. In case of conductor, dielectric constant K is equal to infinity. Okay, capacitance. Now what happens to the capacitance when the conductor is placed between the plates of capacitor? K into epsilon naught A divided by D, its capacitance becomes infinite. Similarly for different materials, if you consider the case of water, just for example, water, K value is nearly 81 or 82. Similarly for paper, different K value. Similarly for plastic, different K value. Ceramic, different K value. So depending on the dielectric medium, that is K value is different for different medium, capacitance will have different values. I think it is clear. Okay, so in the presence of a dielectric medium between the plates of capacitor, capacitance of a parallel plate capacitor is given by, when dielectric medium is introduced between the plates of parallel plate capacitor, its capacitance is given by K epsilon naught A divided by D, where K is called dielectric constant. Sometimes it is represented as epsilon R, that is called relative permittivity, that is also okay. Epsilon naught permittivity of free space, A area of the plates, and D is the separation between the plates of capacitor. Okay, that is C dash. Now if you divide these two equations, if you divide C dash by C, what we get? K epsilon naught A divided by D divided by epsilon naught A divided by D. Epsilon naught A by d, epsilon naught a by d cancels. So C dash divided by C is equal to K. K is equal to C dash divided by C. Now this is the definition of dielectric constant. How to define this dielectric constant in terms of capacitance? Dielectric constant of a medium is the ratio of capacitance of a capacitor. Okay, dielectric constant is the ratio of capacitance of a capacitor. Capacitance of a capacitor with the medium as dielectric ratio of capacitance of a capacitor with the medium as a dielectric, that is C dash, to capacitance of same capacitor. Okay, capacitance of same capacitor with now what is C? C is the capacitance when dielectric medium is air, with the air as dielectric. So dielectric constant of a medium is defined as, it is the ratio of capacitance of a capacitor with the medium as a dielectric to the capacitance of the same capacitor with the air as dielectric. Okay, so in terms of capacitance we can define a dielectric constant. I think it is clear. At this point of time we will solve one problem. After that we will take a few more special cases which is not included in your theory syllabus, but it is important from the point of view of competitive exams. Okay, now let us solve one problem here based on this. The capacitance of an air-filled parallel plate capacitor is 15 picofarad. First sentence. Capacitance of an air-filled parallel plate capacitor is 15 picofarad. Okay, let us list the terms. Capacitance C, air-filled, therefore I will use same notation, C is equal to 15 picofarad. If the plates have an area each equal to 25 into 10 power minus 4 meter square, area of each plate, that is capital A value is given, area is equal to 25 into 10 power minus 4 meter square. Find the distance of separation between the plates. So in the first case what we have to find? D is how much? What is the separation between the plates of capacitor? Now this is the case of air-filled capacitor, therefore K is equal to 1, or we can use the equation that we derived. Next, the second part is, how can you increase the capacitance to 130 picofarad without disturbing the geometry? Let us discuss second part later. First of all, let us calculate D value. Capacitance of an air-filled capacitor is given by C is equal to epsilon naught A divided by D. We have to calculate the value of D, therefore D is equal to epsilon naught A divided by C. Substitute the values. Epsilon naught value, that is 8.854 into 10 power minus 12, permittivity of free space, into area value is given, area is equal to 25 into 10 power minus 4 divided by capacitance is 15 picofarad. Pico means 10 power minus 12. Okay, capacitance is 15 into 10 power minus 12. 15 picofarad. See, generally capacitors or capacitances are in the range from microfarad to picofarad. So it is normally we use capacitor of that range. Farad is a very large unit. Okay, so capacitance is this much. Calculate the value. 10 power minus 12, 10 power minus 12 cancels. 5 times. So that is equal to If you can use calculator for calculation purpose. If I take this is equal to 9, then 9 into 5, 45 divided by 3, so 15, 45 divided by 3, 15 into 10 power minus 4 meter, that is the separation between the plates. You will get 14 point something because 8.854. So you calculate using the calculator. 15 into 10 power minus 4 meter, which can be written as some 1.5 into 10 power minus 3 meter. Therefore, that is equal to 1.5 millimeter. This is approximate value. Exact value will be 1.4 something. Okay. So this is the separation between the plates of capacitor. Separation between the plates of capacitor. Let us go for the second part of the problem, that is, how can you increase? See, original value of capacitance is C is equal to 15 picofarad. We want to increase the capacitance to 130 picofarad, that is C dash is equal to 130 picofarad, but without disturbing the geometry. What do you mean by that? Without disturbing the geometry. Without disturbing the geometry means without changing the dimension. Okay, three possibilities are there to change the capacitance of a parallel plate capacitor: by changing the area, by changing the separation between the plates. That will result in change in dimension or change in geometry of the capacitor. But it is given that without disturbing the geometry. That means only one possibility is capacitance can be increased, or in this case we have to increase the capacitance by using a dielectric medium. So how can you increase the capacitance without disturbing the geometry? Means by introducing a dielectric medium. Okay. Now what about that dielectric medium? What is the dielectric constant of that medium? The dielectric constant of that medium can be calculated as K is equal to C dash divided by C. What is the value? 130 pico, that is 130 into 10 power minus 12 divided by initial value 15, 15 into 10 power minus 12. Okay, 10 power minus 12, 10 power minus 12 cancels, 130 divided by 15. 135 divided by 15 is 9. Now 130 divided by 15 means it will be somewhat around 8.6. I think it is 8.6. Okay, K is equal to 8.6. K is equal to 8.6. Therefore, capacitance of the capacitor can be increased to 130 picofarad by introducing a dielectric medium of dielectric constant 8.6. That is the conclusion. Without changing the geometry, if you introduce a dielectric medium of dielectric constant 8.6 between the plates of capacitor, then its capacitance increases from 15 picofarad to 130 picofarad. Okay, 15 picofarad to 130 picofarad. So this is the answer for second one. Just write a conclusion. Capacitance can be increased by introducing dielectric medium of dielectric constant 8.6. Now, next two more simple things. See, in previous discussion, this was the condition: first plate, second plate of the capacitor. When it is air-filled capacitor, its capacitance is equal to epsilon naught A divided by D. When you introduce a dielectric medium of area equal to area of each plates and thickness is equal to separation between the plates of capacitor, if K is the dielectric constant of this medium, now the capacitance is given by C dash is equal to K times epsilon naught A divided by D. This is when the separation between the plates of capacitor is replaced by a dielectric medium whose area is equal to area of each plate and thickness is equal to separation between the plates, K into epsilon naught A divided by D. Now two more possibilities are there. Now these points are important from the point of competitive exam. Just try to remember these form equations. Okay. Now again same capacitor. Now imagine the region between the plates of capacitor is replaced by different dielectric mediums. For example, I'll use two dielectric media here. Just for example, from here to here, one dielectric medium. Next, here to here, another dielectric medium. Okay, second dielectric medium. In this region, no filling. That means in this region, air remains as it is. Now, if this is the condition, is it possible to calculate the capacitance, or what is the equation to calculate the capacitance of a parallel plate capacitor? Now, this type of question you can expect in competitive exams. Now, let T1 be the thickness of this plate or this dielectric medium. Let T2 be the thickness of this medium. What about the area of cross section? Area of each dielectric medium is the same as that of area of each plate. Now this is the plate. I placed one dielectric medium here. Area of the dielectric is equal to area of plate. I placed one more dielectric here. Again area is same. In the remaining part, no filling. That means air remains there. Okay. Now here air will be there. Let K1 be the dielectric constant of this medium and K2 be the dielectric constant of this medium. If air is the third dielectric medium, what is the dielectric constant? It is equal to 1. Dielectric constant is equal to 1. Now in this case, total separation, it is D, separation between the plates of capacitor. Now in this case, what is the expression for capacitance? Now for this case, capacitance is given by C dash is equal to numerator epsilon naught A, it remains as it is, divided by thickness of first dielectric medium, that is T1 divided by its dielectric constant, plus thickness of second dielectric medium, that is T2 divided by its dielectric constant, that is K2. Okay. Third dielectric medium is air. What about its thickness? Total is D. This part is T1, this part is T2. So total is T1 plus T2. That means this separation is D minus T1 plus T2. So this will be plus thickness of air is now D, original thickness, minus T1 plus T2. Okay, T1 plus T2 divided by, what is the dielectric constant? It is equal to 1. If I have three different media here, one more, if I add one more, it becomes T1 by K1 plus T2 by K2 plus T3 by K3 plus D minus T1 plus T2 plus T3 divided by 1. Okay. What happens if the region is completely filled like this? Third medium. If I introduce third medium of dielectric constant K3 and thickness T3, what happens now? No air, therefore this equation will be epsilon naught A divided by T1 by K1 plus T2 divided by K2 plus T3 divided by K3. If there is some region is filled with air, if there is some region is filled with air, then only this term comes divided by one term, otherwise this will be the condition. Okay, this is the formula to calculate the capacitance of the capacitor when a number of dielectric media having same area but different thickness is introduced between the plates of capacitor. You can use this formula for n number of dielectrics. Okay. Instead of this, if I place a metal sheet here, in the third region, if this part represents a conductor, then what will be the condition? If the third part is a conductor, we know that the dielectric constant of the conductor is infinite. So T3 divided by infinity, this term will be 0. Equation reduces to T1 by K1 plus T2 by K2. So when the conductor is placed, dielectric constant is equal to infinity. Remember all this formula. If air is there, dielectric constant is 1, dielectric constant of different media, and so on. So now this is the formula. This is for this particular case. In the third region, air, dielectric constant is equal to 1, thickness is this much, that is d minus thickness T3. Now this T3 is equal to d minus T1 plus T2. For any number of dielectrics you can use this formula. Okay, next, one more possibility. If the dielectric medium between the plates of capacitor is filled like this, one medium of dielectric constant K1, another medium of dielectric constant K2. In the third region, I'll simply leave that region. That means in this region there will be air. If this is the case, what is the difference? Here area of each dielectric medium is equal to that of plates of the capacitor. In this case, thickness of each dielectric medium is same as the separation between the plates, but area is different. This dielectric medium covers only this much area of the parallel plate. This dielectric covers only this much area, here this much area, like this. Previous case was this one, dielectric medium placed on the plates of capacitor, different dielectric media, area is same, thickness is different. Now in this case, first dielectric medium is placed like this. Okay, thickness is same as the separation between the plates, but it covers only a part of the plate. Second medium covers a part of plates of the capacitor, like that. Now if this is the case, if D is the separation between the plates of capacitor, then capacitance in this case is given by C dash is equal to epsilon naught divided by D. D is same here, epsilon naught divided by D. Now here A is nothing but it is the area of each plate. Epsilon naught divided by D into first medium K1 into area covered by that medium. If A1 is the area covered, if it covers half area, then A1 is equal to A divided by 2. Area, that is K1 into A1. If this medium covers an area of A2 of each plate, then plus K2 into A2. Okay. If this area is A3, if it is air, then dielectric constant is 1 into A3. Okay, instead of conductor, if I use air, if I use conductor, then instead of 1 you have to use infinity. Straight away capacitance will go to infinity. So 1 into A3. So if I use only two dielectrics without any air gap like this, then formula will be this one, K1A1 plus K2A2. You can use this formula for n number of different dielectrics. Okay, I think it is clear, these two equations. Let us solve two problems based on these two expressions, which you may find in competitive exam, which will give you a clear idea regarding this equation. Okay. Go through the problem. A parallel plate capacitor has a capacitance of 4 microfarad. Capacitance of a parallel plate capacitor, that is with the air as dielectric, that is the meaning, 4 microfarad. Okay, 4 microfarad. If the space between the plates is now filled with a dielectric slab of epsilon r is nothing but dielectric constant. You can use K or epsilon r for dielectric constant. Epsilon r is equal to 2, having the same thickness, as air gap, so as to cover half of the area of the plates. Try to understand the things given in the problem. Capacitance when air is used as dielectric between the plates of capacitor is 4 microfarad. Now I'll write the expression here. C is given by, for air filled capacitor, epsilon naught A divided by D is equal to 4 microfarad. Now space between the plates of capacitor is filled with the dielectric slab of ER, that is relative permittivity is nothing but dielectric constant is equal to 2. So that, let us try to write the diagram. Okay, diagram. So as to cover half of the area, but the thickness is same. That means a dielectric is introduced like this. Dielectric medium is introduced like this. Thickness of the dielectric medium is same as the air gap between the plates of capacitor, separation between the plates of capacitor. Now this part is a dielectric medium. Now this part represents dielectric medium. Okay, this is first plate of the capacitor, this is second plate of the capacitor, this is the dielectric medium. Okay, now K value is, I'll take it as K1 or okay, K1 is equal to 2 relative permittivity. Area covered by this is given, area is equal to, it covers half of the area between the plates. That means if total area of plates is equal to A, then it covers A divided by 2. So this particular dielectric medium covers area, half of the area, therefore A divided by 2. Now what about the remaining part? Nothing is mentioned in the problem. That means here air remains here. Area of this region is equal to A by 2. We know that dielectric constant of air is equal to 1. Now what is the new capacitance? That is the question. For this you have to use C dash is equal to epsilon naught divided by D, epsilon naught divided by D into K1A1 plus K2A2 plus etc. formula. In this case only two conditions are there, so I'll restrict the formula to K1A1 plus K2A2. Now let us substitute the condition. See, D value, A value, it is not given. If it is given, you can substitute. Such type of problems you can find in exams. Okay, now in this case nothing is given, only the values, area in terms of area of the plates is given. Let us try to solve this problem. Substitute the values. Is equal to epsilon naught divided by D, keep it as it is, into K1 value is given, it is equal to 2 into what is the area covered by first medium is A divided by 2, therefore A1 is A divided by 2 plus what is K2 now, second medium is air itself, dielectric constant of air is 1, K2 is 1, now this is K2 into what is the area covered by this region, that is equal to A divided by 2. Simplify, epsilon naught divided by D into 2 cancels, A plus A by 2, A plus A by 2, total is equal to 3 times A divided by 2, isn't it? A plus A by 2, 3A by 2, so 3 times A divided by 2. So therefore C dash is equal to 3 divided by 2 into remaining part is epsilon naught A divided by D. Just rearrange this equation, 3 by 2 into epsilon naught A divided by D. So C dash is equal to 3 by 2 into what is epsilon naught A divided by D, it is the capacitance in the presence of air, its value is 4 microfarad, therefore 4 microfarad. 2 ones, 2 times, 3 into 2, so C dash is equal to 3 into 2, 6 micro is there, microfarad. Okay, in this case D or A value is not given. If it is given, you can substitute the values. So new capacitance is 6 microfarad. I think it is clear. Next, one more problem. parallel plate air capacitor has a capacitance of 2 microfarad. Again, starting sentence is same. Capacitance of air capacitor epsilon naught A divided by D is equal to 2 microfarad. When the gap is filled with the dielectric medium of dielectric constant 3, so gap is filled with the dielectric medium of dielectric constant, that is K1 is equal to 3, so as to cover the full area, okay, so as to cover the full area but half thickness. Let us visualize using diagram. Now dielectric medium is introduced between the plates of capacitor. In the previous case, the dielectric medium introduced such that it covers only half area. Now in this case, dielectric medium is introduced so as to cover full area but half the thickness. Now dielectric medium covers full area. Okay, so the dielectric medium covers full area. Now area covered by the dielectric medium is equal to area, but the thickness is half. Now this part is D by 2, this part is remaining is D by 2, so that total thickness between or separation between the plates is equal to D. Now dielectric constant is K1 and thickness, let it be T1, and let this thickness be T2. Now there is nothing is there regarding this part of the capacitor. That means here air will be there. Dielectric constant, if I consider it as K2, then its value is equal to 1. Dielectric constant is equal to 1. Okay, if you want you can write K2 here. Now what is the capacitance? Now for this case you have to use this equation. C dash is equal to epsilon naught A divided by T1 by K1 plus T2 divided by K2. Only two media are there. If you have number of dielectric medium, then you can continue this T3 by K3 and so on. So that is equal to, again values are not given, D or A values are not given. Let us try to solve the problem. So epsilon naught A divided by T1 is D by 2 divided by K1 value is given, T1 is equal to D divided by 2, half thickness, K1 is 3 plus remaining part is D by 2 is the thickness, that is T2, divided by dielectric constant of this, that is air. Dielectric constant of air is equal to 1. So that is equal to epsilon naught A divided by, this will be D 3 into 2, 6, D by 6 plus D by 2. So that is equal to epsilon naught A divided by 6 over D plus 3D. Okay, 6 is the common denominator, so into 3D. This 6 comes here is equal to 6 epsilon naught A divided by D plus 3D, that is equal to 4D. Okay, D plus 4D. So therefore C dash is now, C dash is equal to 6 divided by 4 into epsilon naught A divided by D. 6 by 4 into epsilon naught A divided by D, that is equal to 6 by 4 into epsilon naught A divided by D is 2 microfarad. So into 2 microfarad, 2 microfarad. So 2 ones, 2 times, 2 ones, 2 3 times. So remaining is, that means C dash is equal to 3 microfarad. Answer is 3 microfarad. If this is the condition, then capacitance of the capacitor is equal to 3 microfarad. Okay, I think it is clear. Let us continue the discussion in the next class. Thank you so much.